Hello everyone, I am S. Kavita, working as Assistant Professor at Kamaraj College of Engineering and Technology. In this video, we are going to see about the problem in signal flow graph. In this problem, we have to identify the input node. Plus, how many nodes are here? 1, 2, 3, 4, 5, 6, 7. Totally 7 nodes are there and 7 gains are also there. And it contains feedback loop, no self loop. So, input node is RFS and the output node is CFS. Look at the forward path. We have to start from input node to the output node. You have to travel the node only once. This is the rule for the forward path. If it is so, how many forward paths will come here? Starting from RFS to V5, V4, V3, V2, V1 and then CFS is a one path. Write the path gain. P1 node starting from G1 of S is multiplied with G2 of S, G3 of S, G4 of S, G5 of S, G7 of S. Note it down. Here the value is G7. So the node is traveling straightly. And the second forward path, whether it is any possible for second forward path, we have to check with all the nodes. Here it is a feedback, so no need to consider. Here also it's a feedback, here also feedback, but look at this node. It is a forward path. So the second forward path is P2. In this forward path, the gain is first starting from RFS, so gain is G1 of S, G2 of S, G3 of S, G4 of S, and here we have to travel G6 of S, G7 of S, and we are finally reaching the output. So this is the forward path. And how many loops are here? From the diagram we can come to the conclusion that this is loop 1, this is loop 2 and this is loop. So first the loop L1, what is the gain of this loop is G2 of S into H1 of S. The loop 2 G4, that is G4 into H2 of S, and the loop 3 is G4S, G5S, and then the feedback path is H3 of S. So this is the feedback loops. So look at the diagram, the forward path gain, and there are 4 loops. First loop, second loop, third loop, and the hidden fourth loop is here. Starting from G4, G6 and then it is ending at the load. So the fourth loop is G4 of S, G6 of S, and the last one is H3 of S. Now consider about the non-touching loop. Here consider the node. For this loop, V2 node is travelled once and V3 node is travelled once. But considering the second loop, that is a G4, G5, G6 and H3, the node is touching twice. So it is not admissible. This is a touching loop. Similarly for the loop 4 also, here also it is a node is common. So the non-touching loop is 3 possible combination because the loop 1 is a non-touching loop with loop 2, loop 3, loop 4. So this loop is considered as a non-touching loop and the loop gain is multiplied with this combo. That is G2 of S into H1 of S is multiplied with G4 of S into H2 of S for the first case, and for the second one G2 H1 is multiplied with G4, G5 and H3, and for the third combo G2 into H1 of S is multiplied with G4, G6, H3 and then H1 of S. So these are the 3 non-touching loop gains. So this is about the basic things what we have discussed is. From the graph we have come to the conclusion that we find out the input node, output node, path, feedback path, the loop gains as well as the non-touching loop. So warm greetings. Today we are going to solve the problem in signal flow graph. Just a recall, signal flow graph is a diagrammatic representation to solve the control system problem. It is a easier method which uses the Mason's gains formula. First the given problem statement is we have to find out the transfer function of the system. Here is a total of 8 nodes is there. Input is RFS and output is CFS. So the transfer function is Laplace transform of output divided by Laplace transform of input, that is the CFS is divided by RFS. First step we need to find out how many paths is available. The path is starting from the input node and it reaches the output node. Each node should travel only once. So in this problem we are having 8 nodes and the forward path we have to observe, and then the loop we have to recollect the loop. Loop is a node where the path travels and reaches back to the node again. So how many loops is available here? Totally 3 loops is available here. Okay, we will proceed with the steps. The first step is we need to find out the forward path. In this problem we are having 2 forward paths and starting from 1 to 8 node, and we have to find out the forward path gain with the notation P1, as 1 indicates the forward path 1. So we have to multiply all the signals flows here, 1 into G1, G2, G3, G4, G5, and this is the forward path 1 gain. And the second forward path starting from 1 to 2 and it travels from 2 to 6 and then it again reaches 6, 7, 8, and this is the second forward path. And the forward path gain for this is we have to multiply the signal flow through it, and here we are representing the number 2 which indicates the forward path 2, and we have to multiply the signal G6, G4, G5, and we are writing it in the order, that is G4, G5. And the second step is we need to find out the individual loop gain. So look at the problem. How many loops are here? Here the first loop is G2 into minus H1, that is traveling the node 3 and 4. And the second loop is traveling from 6 to 7, that is G5 into minus H3, and the third loop, that is starting from G2, G3, and then it is feedback to the node 3. So the path gain is G2, G3, and then minus H2. So this is the individual loop gain, and here we have mentioned a 2-digit number, and it represents this is the single loop, and in this 3 loops it is the first one that is mentioned in the first number. So the P11 indicates it is the first loop in the single loop, and this is the gain. We have to multiply the signal along with its sign. So for the path of gain P11 is minus G2H1, similarly for the gain P2, and this is for the individual loop gain 3. Next step is, in step 3 we need to find the gain product of 2 non-touching loops. Already mentioned, same node should not be shared with the loops. So in this problem we can come to the conclusion that there are 2 possible non-touching loops are there. One, the node is 3, 4 is not touched with the loop 6 and 7. Similarly, the node 6 and 7 is not touched with the loop 3, 4, 5. So here also we have to find gain 2. Here the 2 indicates the 2 non-touching loops, and this is the combo, first combo, so it is mentioned as P12 minus D2 into H1. For this loop is minus D5 into H3. When we are product, minus into minus will become plus, and we have to write it in the order. So G2, G5 int, and then H1 into H3. Similarly for the second loop, minus G2, G3 and H2 is for the first loop, and the second 6 to 7 node is minus G5, H3, and we are producing it so that we get the output as G2, G3, 5, H2, H3. So this is the output of the gain product of 2 non-touching loops. Fourth step is we need to find out the del as well as the del I. The del I that is given by 1 minus sum of individual loop gain plus sum of 2 non-touching loop gain minus sum of 3 non-touching loop gain, and then it goes on. In this problem we have only 2 non-touching loop. For this case we have to consider and rewrite the given expression as 1 minus the loop individual loop gains is we have obtained 3. So P11, P21, P31, and 2 non-touching loop is P12 and then P22. So I am substituting the values of P11, P21, P31 as well as P12 and P22, and summing up together we get the output as the del, that is 1 plus G2 H1 plus G2 G3 H2 plus G5 H3, and then G2 G5 H1 H3 plus G2 G3 G5 H2 H3. This is about the del. And what is del I? Del I is the forward path 1. In the del 1, sum of loop individual loop gain and sum of non-touching loop gain that is not connected with the del. So this is not possible. So these are loops is already touching with the forward path of 1. So I have to put 1 minus 0, that is 1. In the second forward path, we have to find out the same thing. Here, there is a possibility of non-touching loop is available in the forward path 2, as 3 and 4 nodes is not even touched. It is 1 minus sum of individual loop gain plus sum of 2 non-touching loop gains. So for this particular forward path 2, so I have to substitute the value of P11 and I have to find out the value of del 2. So in this problem we have find out up to the 4 steps, that is forward path, individual loop gain, as well as the non-touching loop gain, and finally we have del of the transfer function. So the last step is we have to substitute in the transfer function formula that is given by the Mason's gain. The main formula is transfer function T equal to 1 divided by del into summation of I equal to 1 to n pi del I, where I values varies up to the total number of forward paths. In this problem we have found out the forward path as 2, so we have to substitute for the two values, P1 del 1, P2 del 2. So substituting all the values we have found out del value here, and then P1 value which is multiplied with the del 1 and P2 is multiplied with the del 2. So after substituting and calculating just by adding and multiplying the common terms, and we taking the common terms out, so that we come to the final conclusion. So this is about the signal flow graph reduction for a given control system problem. Thank you.